gonna get ready. So tell me who you are.
So I'm Wayne Green. I'm Dean of School of Medical, Molecular and Forensic Sciences here at Murdoch. And I've been Dean now for about 12 years, so quite a long time. Did you want to hear about my background as well?
We're going to do
Yep.
that
Oh, okay.
afterwards.
Yep.
So tell us about the school and the programs offered under your school.
Okay, yep. So we have 3 bachelor programs at undergrad level. We've got a Bachelor of Laboratory Medicine. It's a 4-year program that is nationally accredited by the Australian Institute of Medical Scientists. We have, and that trains students to work in medical diagnostic laboratories.
Okay.
We have a Bachelor of Food Science and Nutrition. So that, as the name suggests, means students can move into the food science sector, working for food companies, around developing new novel foods, improving foods, looking after food quality. Or they can move into nutrition, human nutrition, and if they're really keen on nutrition, they can move on and do a postgraduate Master of Dietetics after having completed that degree to become a dietitian. So we've got that program, and then probably our biggest program is the Bachelor of Science, and at the moment we have 5 majors that sit in that course, biomedical science, and that trains students really, it's good preparation for postgraduate medicine, or a big outlet for those graduates is medical research, moving on into the research world, or working in the biomedical sales and marketing sector, for example, or other related areas, working for the government in the health and the medical side. So it's really an all-purpose degree, biomedical science. There's a whole range of different areas students can work in. We've got clinical laboratory science. Now that is similar to laboratory medicine, except it's not accredited, and it's a 3-year program, not a 4-year program. Now that would suit students who don't necessarily need the accreditation. They might be wanting to work in a medical diagnostic lab in a state of Australia or a country where the accreditation is not specifically required, and that saves them a whole year of study and the costs associated with that. Or it might be for students who are wanting to delve into the world of medical diagnosis without necessarily work in a pathology lab. Maybe they want to get into research around diagnostics and things like that. We have genetics and molecular biology, which, as the name suggests, is all about DNA, genes, gene technology, genetic engineering, manipulating DNA to create new products, for example using bacteria, all that kind of thing. Gene editing with so-called CRISPR technology. So that's a real core science in the life sciences, is genetics and molecular biology. And graduates usually apply that to a particular field. They might apply that to the medical science side, or to the agricultural side, for example, or veterinary side. What else have we got? We've got our forensic courses, and we've got forensic biology and toxicology. So forensic biology is, as the name suggests, it's using biology to work out who's responsible for a crime, or to work out the victims in a disaster situation. So the main tool there is DNA. We use DNA to identify either criminals or people, but there are other ways we can use biology as well. For example, entomology, the study of insects. You can tell how long something has been dead, for example, by the composition and the insects that have infested a deceased person or animal. There's also marine forensics, so we can tell how long something's been in the water based on the barnacles and other sea life that's attached itself. So forensic biology encompasses more than just DNA, but a range of things. And then we've got forensic chemistry, and that's about using the chemical side of the equation to uncover crimes. So, with forensic chemistry, you're talking about like gunshot residues, drugs, and all that side of things, because you can't really use biology so much. You need chemical tools to work with that side of the field. So that encapsulates our undergrad programs. Then we've also got postgraduate courses. So we've got a Master of Forensic Science. So students who really want to specialise in forensic investigation can go on and do our Master of Forensic Science. We've got a Master of Food Science, so those doing the undergraduate food science and nutrition program can really specialise in the food science side. And we have a fantastic facility south of Perth. It's a dedicated food science technology facility.
Right.
There's industry there, there's bakeries, breweries. We've got government located there as well, so it's a fantastic facility, for food science and networking with industry and government. And that's called the Food Innovation Precinct WA, or FIPWA. We are starting a Master of Infectious Disease this year.
Okay.
So that is for students who want to go right into that infectious disease field, whether it's virology like COVID, or bacteriology, or public health,
right,
and food safety, all of that kind of thing. So we've also got a Master of Infectious Disease coming. And our fourth Master's program is one with, it's a collaboration with the Australian National Phenome Centre, the ANPC. That's the best facility of its kind in the Southern Hemisphere. Okay. And it looks at metabolites, so small chemicals in the body, blood, and you can use those as markers to identify disease processes, including COVID. So we have a Master of Systems Medicine, it's called, which is it's a systematic way of looking at all the biochemicals in the body to help understand disease processes, whether that's cancer or heart disease or viral infections.
Will they be able to identify whether you are likely to get it?
Exactly. That's exactly the emphasis on the research that's taken place in the last few years, is identifying through biochemical markers who is susceptible to severe COVID and who's not. And they have actually published work showing markers to identify people who
So I could go and get you pull my blood, and you can go and take a look and tell me what I might be susceptible to.
Exactly.
Scary, but I'm still curious. Scary. All right, I had COVID twice, so I wonder why.
Yes. Well, I've had COVID twice too.
Oh, really?
Yeah. I think most of us now have had COVID at least once, I'd say. Yeah, and it's still circulating.
Yes, it is.
It's mopping up those that haven't had it yet.
Did you guys do a lot of research on COVID since the pandemic?
Yeah, look, two main areas of this university did research on COVID. So the Australian National Phenome Centre, as just mentioned. Also, we have a what we call the Antimicrobial Resistance and Infectious Disease Laboratory.
Okay.
And they are looking for new drugs, new treatments for COVID, for treating COVID. So, but they didn't use the COVID virus, they used a related virus, because we didn't want to be working with the actual COVID in our labs. But they're using a similar virus to identify drugs that might, not novel drugs that can treat the disease.
So technically COVID is not going away.
No. Well, it's becoming less of an issue, right? It's become endemic now at a low level, circulating. It's not a pandemic anymore, but it's still an issue, That's right. Yeah.
Okay. So you've mentioned quite a wide range of programs at both the undergraduate and postgraduate level. Now, I know what's trending all across the world is making sure that persons get practical experience. So it's not just the theory part of it, but how they can apply their skill set. So what opportunities at either level of the programs available do students get a chance to actually practice?
Yeah, great question. There are three. If someone said to me, what are the three things about Murdoch that we would promote and why students should come to Murdoch, one of them is we really emphasise practical experiences. It's only when students get into a lab or a fieldwork situation that they can really engage with a theory and really reinforce the theory. So we very much are about offering practical experiences in all of our units, or most of our units.
Mm-hmm.
We've also got work placement units that students can undertake.
Okay.
So they can be put in a real functioning, for example, laboratory.
Okay.
As part of their studies.
Okay.
Beyond that, we encourage particularly our Bachelor of Science students to go on and do an honours year. That's a fourth year, which is designed to put students in a real workplace. So they spend effectively the best part of a year in a real lab doing real research, working with a real team, and they come out completely transformed from that experience.
Okay. Now I'm going to center in the forensics a little bit, because that is an area that many people find fascinating, thanks to Law and Order, CSI, and all those other crime type pictures. I actually originally started to study forensic science, so I know that those pictures are not really a true depiction of forensic science. But you seem to have, this seems to be a signature program for you. And actually our student, Lisa, would have done the program here, and she's still here working. So tell us a little bit, what makes your forensic science program special?
Yeah, you're right, it is quite a signature program for us. We were the first in Western Australia to set up a forensic biology program.
Okay.
We've been able to attract some very good forensic investigators who've got great experience in the industry. They know what they're talking about. They've worked with homicides and all sorts of crime cases. So they bring real credibility to our course.
Nice.
And we've been able to build quite a solid, sizable team now. We're not just relying on one or two people. We've got a sizable team of academics working in the forensic field. We're also the only ones that offer both an undergraduate and a postgraduate program, so a student can go right through. They can learn the basics during their undergraduate and then go right into the depths of homicide investigation, etc. in the Master of Forensic Science. So we've got a full suite of programs to offer students with very credible, experienced staff. And another advantage of Murdoch is we're very much about looking after our students, not treating them like a number, but actually nurturing the students all the way through. So, and they get that as part of our forensic program. Often students are on first name basis with their lecturers, and we have an open door policy. You know, if students need help, we're there to help them. So, because I know some universities can be quite elitist, where no, you can't go see the unit coordinator. No. You've got to go through your tutor first, or something like that.
Right.
So, we very much about nurturing our students. And the third thing I'd say about Murdoch, on top of that, is the flexibility we offer. So I've mentioned a variety of majors earlier, biomedical science and forensic biology, etc. What I didn't mention though is that you can combine two majors together in a 3-year program. So if you want to do forensics and biomedical science, that's not a problem. You can do a double major in a 3-year period. So we have a mix and match double major system.
That's heavy though.
No, it's no more work, because at the end of the day, to get your Bachelor of Science, it's 3 years of study full time.
Right.
And whether you do a single major or a double major, it's the same amount of work. It's just that if you did a single major, you would have to pick up elective units to fill in the gap. Or you have another strategy, you can just use your electives
To do the double.
and take a double major.
Right.
So if you're not sure if you want to do forensics or biomedical science, you can do both. So
So you don't have to choose. You don't have to choose
exactly.
so early on, right? And that will give you more versatility even in the labor market, because you have an enhanced amount of skill sets and knowledge.
Exactly, that's right. And for example, if you do, let's say genetics and molecular biology is your first choice, as I mentioned before, that's a core science, but you normally apply it somewhere. So you could combine genetics and molecular biology with biomedical science to go into medical research, or with crop and pasture science to go into plant science. So, for example, you've got a whole variety of...
You could get creative.
Yeah, and you can do double majors outside of our school. You could do biomedical science with chemistry, if you wanted to get into, say, drug discovery and pharmaceuticals.
Right.
So, yes, we have a very flexible mix and match model.
Oh, I like that. So tell us about your specialty area.
So I was actually the first in my family to go to university.
Oh.
So Yeah, probably not unusual going back to my generation and earlier. So I just stumbled my way through university. I thought, what am I going to do now? Oh, I'll do honours. Okay, did an honours year. Oh, what am I going to do now? Oh, let's do a PhD. Stumbled my way through. And then actually my first job was here at Murdoch University, would you believe? So after I graduated with my PhD, so I worked in a variety of areas. Started out working in allergy, house dust mite allergy in children, and then flea allergy in dogs. So that's what brought me to Murdoch.
Okay.
I worked on a virus then called the feline immunodeficiency virus, FIV, which was being used as a model for human HIV infection.
Okay.
From there, I picked up a fellowship and went to Cambridge in the UK.
Nice.
And
Which Cambridge? Which school in Cambridge?
so it was the Medical Research Council Laboratory of Molecular Biology, the MRC LMB, which is associated with Addenbrooke's Hospital in Cambridge. That's a very famous lab. That's where they invented monoclonal antibodies, where they discovered the structure of DNA.
Okay.
So a very famous laboratory, and I learnt a lot there.
Okay.
And I changed fields. I had started in allergy and then moved into infectious disease, but then I moved into cancer research.
Okay.
And I was working on human leukemia, childhood leukemia, while I was in Cambridge. From there, I came back to Perth to work at the Kids Institute, as it's now called. So that's a children's research institute, and continued to work on childhood leukemia. And then I was offered an academic position here at Murdoch, and so I relocated here.
So mixture of academic and then practitioner, as a practitioner as well, working in the lab,
Yeah,
doing research, active research.
The first part of my career was 100% research. That's all I did for a number of years. And I forgot to mention that I also spent 18 months in Singapore. I was working on hepatitis C virus in Singapore. That was before I went to Cambridge. So so this is the beauty of science. Particularly if you go on to get a higher degree, you can work anywhere in the world. It's a ticket to the world. It's easy for someone in a lab in another country to employ you over someone maybe local, because you might offer particular skills that may not be there. So so travel and working in other countries is often part of what we do as scientists. As one of the attractive features of a career in science.
So you went from a bachelor straight to a PhD.
So look, there's two ways to do it. Some students like myself do bachelor's, honours, PhD, all one after another. But there's other ways to do it. I know many who might go work for a while and then come back and do honours, or do honours, work for a while, then come back and do a PhD. So either works.
I notice you guys say honours. So it's like an add-on, it's still undergraduate level, so it's not necessarily from a bachelor's to a master's then to PhD kind of.
Yeah, but we also offer the master's pathway. So for example, with the new Master of Infectious Disease, instead of doing honours, students can do their bachelor's, then the Master of Infectious Disease. If they do the 2-year masters, 1 year of that is a research project. So they're getting honours equivalent experience in research.
Okay.
So but they'd come out with a master's degree with higher knowledge plus the research project and the research experience. So we offer both pathways, the 1-year honours or particular master's programs that give you that extra higher level knowledge plus the research experience.
All right, so you've given us a good overview of what Murdoch offers here, and then the capacity for students to get practical experience, real world experience, and then how they can take one level and move to the next and move up. Now, as science evolves, and we know COVID really opened up our eyes to being always cut above the rest or being ahead quite a bit. What's the future areas you see emerging? So for the student coming now or the next couple years, what would their future look like in terms of areas of study that may not be quite developed yet, but maybe down the road?
Great question. I would say molecular biology is really the cutting edge of all the life sciences, not just medical, but agriculture, and other areas. So gene therapy is big. We can help cure, particularly genetic disorders, but also cancer through introducing genes or genetic material into patients to correct disease processes.
Okay.
We now have not only the ability to introduce genes, but we can even think about now using gene editing technology to actually fix genes within patients. So if someone, for example, has got a blood disorder, we can take their blood stem cells out of their body, correct the mutation in those cells, and then put those cells back in, and they will start to produce normal cells again. So this is gene editing technology. So that's really coming along.
So you can soon customize your body.
Yes.
In a sense.
You can, yes.
Can I sign up?
Well,
I might edit that part out. Or I might not.
Also molecular therapies. So I think we saw with the COVID vaccines using mRNA, a piece of genetic material to vaccinate with. So we're seeing a lot of that now. Vaccines based on genetic material, but also treatments. We can use genetic material to manipulate expression of genes as a treatment. And I think COVID has really let the genie out of the bottle there. Whereas before it was stepwise progression and people were being very cautious.
Right.
The fact now that we just basically use this mRNA vaccine across the world in many, many people has, I think, reduced the anxiety level around using genetic material. But that's not to say we need to be mindful, though, that there can be, a small number of people issues with that kind of technology.
Yes, yeah.
And that needs to be also investigated and addressed, for sure. But molecular is a big area. So I would, for that reason, I would strongly recommend any student wanting to do a major in biomedical science. I often would recommend they do their second major in genetics and molecular biology, because those two go together so
really well. Yeah.
The other area that's really coming along is at the cellular level, stem cells. So we're developing technologies to produce stem cells. We can make stem cells from your skin or blood.
Okay.
And then we can coax those stem cells to turn into whatever we want, liver cells, heart cells, whatever. So that technology is still very much in progress and is going to lead to good things going forward, and we've already seen evidence of that. So stem cell technology, and also immunotherapy. So this is where we take lymphocytes. So lymphocytes are the key white blood cell responsible for our immunity in the blood. We can take those out, we can genetically modify them to attack cancer cells and then put them back. And this is really coming along very nicely as well, this technology. So that's another field. So molecular therapies, gene therapy, stem cell therapies, all of that is I think really at the cutting edge. But let's not forget about our biochemistry side, the metabolomics and the kind of thing that the Australian National Phenome Centre do as well. They look holistically at the whole body and what's going on, and looking for markers of disease and all that kind of thing. So with biomedical science, you can be down at the small molecule, at the biochemical level, or at the gene level, or at the cell level. There's a range of areas that you can work in.
Science have evolved even from when I was thinking about university and to now. So it seems like to be exciting and fascinating. You've spoken about things that you might only think about or not even have thought about. So let's talk about Caribbean students, and for those who might be considering other destinations to come and study and explore. And I believe fundamentally international education for networking, enhancing knowledge, and I think we bring our flavor to your classrooms as well. But what will you tell them? I know Australia might seem far for many. Me having been here, I'm really falling in love with this place. So what would you tell them, and why would they consider Murdoch, and why Western Australia?
I think, one good thing about Caribbean students coming to, say, Western Australia, Perth, or Australia in general, to be honest, it won't feel that strange to them. I think the Caribbean was largely part of the British Commonwealth, as we are. We play cricket, so against each other.
We're not going. We're going to skip the cricket for a little bit. we're not doing so well there sometimes.
Well, I'm old enough to remember when the West Indies did very well. So culturally, there's some similarities there. I think that's one thing. We're very friendly, laid back. So I guess I believe the Caribbean is somewhat laid back as well.
Yes.
So I think there's similarities around culture there as well. We're also a relatively safe place in the world, so it's safe for students. And well, if we're talking Perth, we've got great beaches here.
Yes, I've seen. Yes, yes.
Similar to the Caribbean. Well, I'm not saying similar in that we have beaches. I'm not saying our beaches are the same, but maybe up north they might be more similar. They're the main things I can think of at the moment. Yeah.
So it's definitely a possible good fit, because I don't feel the change as much as I feel it going to other destinations. I was telling some of the others earlier. You feel a difference when you hit the UK, or you feel that difference even in Canada. But here, I was like, this reminds me of home.
Well, that's right. I mean, and of course we share the English language, but also we're a relatively warm place, so we're not going to feel strange like Canada might. So I think there's more similarities and differences really when you think about it. Don't mind the distance or how far apart. I don't feel it as much. Not as much as I thought I was going to feel it. So it's really interesting. Well, I really want to thank you, Dr. Green, for taking this time and talking to me, talking about the programs. I know we've had one student in that went through your forensics, and I definitely have been following your forensics. There's a forensics page on Instagram. I do follow the work that they're doing. But I want to know a little bit more after I turn off this camera about getting my DNA changed. So how I can sign up for that to cure me of my flat feet, so I can hopefully someday wear heels. But thank you so much, Dr. Green, for hosting me and for all the information. Thank you so much. No problem at all. It's been fantastic talking to you.